Alright class, in this video I'll be doing the third example from section 5.3. Use the given zeros to find the remaining zero and then write as a product of linear terms. So r of x is a fourth degree polynomial. So what we should expect is 4 complex roots. And real numbers are complex, so they can be part of the zeros. So to start, we're going to use the given root, negative 5i, and synthetic divide. All right, when we synthetic divide, remember we bring the first number down, and then we multiply. Negative 5i times 1. And negative 5i times 1 happens to be negative 5i. Now, unfortunately, we cannot add a 1 to a negative 5i. However, we can write the complex number as negative 1 minus 5i. And now we're going to have to multiply negative 5i times negative 1 minus 5i. So I'm going to do that below. So we distribute, that'll be a positive 5i plus 25i squared. And since I squared is a negative 1, the result is a negative 25 plus 5i. So that is what we're going to add to our 19. Now 19 minus 25 is negative 6. And that's plus 5i. So again, we're going to multiply the negative 5i by the negative 6. So negative 5i times negative 6, and we're going to multiply it by the 5i as well. So that's 30i minus 25i squared. Since I squared is negative 1, this is positive 25 plus 30i. So this will be 25 plus 30i. Negative 25 plus 25 is 0. So this sum is 30i. And when you multiply negative 5i by 30i, you will get positive 150. So the remainder, as you should have already guessed, is 0. And again, the remainder is 0 because negative 5i is a 0, or is a root. All right, what are we going to do from here? Well, by the conjugate pairs theorem, since negative 5i is a root, positive 5i will also be a root. So we're going to synthetic divide again by another complex number. Here we go. Bring the 1 down. 5i times 1 is a positive 5i. Negative 1 minus 5i plus 5i is negative 1. 5i minus or times a negative 1 is negative 5i. So I'm going to add a negative 5i to negative 6 plus 5i, and that should be negative 6. And then 5i times negative 6 is negative 30i. And the result is a remainder of 0. Okay, so what's the factor that's left out of all of this synthetic division is x squared minus x minus 6. And lucky for us, that factors. This factors as x minus 3, x plus 2. And if we want to find the zeros, we set that expression equal to 0. So it looks like we have two rational zeros. One at x is equal to 3, and one at x is equal to negative 2. So now that we have our 4 zeros, we're going to rewrite r of x as a product of linear terms. So the first we're going to write out is x minus 3. And then x minus a negative 2. Our next root is x minus 5i. And with our next root, x minus negative 5i. And that is r of x written as a product of linear terms.